So, climate change is happening. As I mentioned in the previous video, if you look at every metric imaginable, global average temperatures, sea ice, ocean temperatures, the presence of different ecosystems, the presence of droughts, extreme weather, um, something serious is happening. But what is actually happening and what isn't happening? So, what is climate change? Why do we use this term? And why do I personally hate the term global warming? Here we go. So, what is climate change? Well, first, let's actually start with that term that I hate, global warming. Global warming represents the increase in global average temperatures. Um, and we've been taking temperature records since the 1880s. So we have about 140 years of temperature records. And based on all the numbers crunched, based on everything that has been looked at, we have warmed about this number is as of 2014, so it may actually be a little bit higher by now. But we have warmed about 0.85 plus or minus zero point 0.2 degrees Celsius. What this means, this is what is called a 95% confidence interval. So we can say with 95% confidence, that is considered the statistical gold standard, that Earth has warmed somewhere between 0.65 and 1.05 degrees Celsius since 1880. That is a lot of warming in a relatively short time. Now, that being said, why do I hate this term global warming? So, first off, I will say global warming is real. Global warming is happening. The reason why I hate the term global warming, though, is that it is a very misleading term. So imagine, if you will, I give you all a test. We take our first midterm, I give it all to you, and let's say the class average is an 80%. All right, so I give you all the midterm, the class average is an 80%. Now, let's say I decided to give each and every one of you that 80% as your grade. How would you feel about that? Think about that for a second. How would you feel? Those of you who didn't do so well might be stoked. Hey, the rest of the class pulled me up. Those of you who did awesome on the exam are going to be pretty pissed. I would expect some pretty angry emails. I hate these three words, but I would expect to hear that's not fair, because it honestly isn't. It is not a fair representation of each of your individual achievements. Well, when we talk about global warming, what we are actually doing is we are taking the entire planet and using one metric, one number, to sum up the entire planet. And that is not an accurate representation of what is happening. Some places on Earth are warming way more than 1.05 degrees Celsius. Places in the Arctic, near the North Pole, parts of Alaska, Greenland, parts of Northern Europe have seen way more warming than 1.05 degrees Celsius. Meanwhile, other parts of the world, parts of the equator, have seen practically no warming. And in fact, some places have even seen cooling. The North Atlantic, many coastal regions have actually seen cooling. So that being said, to say the world is heating up or everywhere is heating up can be a very misleading statement. And it's very easy for somebody to come along and say, okay, well, what about the North Atlantic? They've been experiencing record cold, so global warming is fake. No, global warming is still real, but it doesn't tell us the whole story. Different parts of our planet are responding to this warming differently. Different parts of our planet are responding to this warming differently. Now, I know that might sound a little confusing, But bear with me, we will actually walk through that more as we progress in this course. So I'm not trying to pull wool over your eyes. Um, but the reality is not everywhere is warming the same amount. So to say global warming and leave it at that is misleading. So that is why the term climate change has come in. And that is why scientists over the past 20, 30 years have sort of swapped out global warming for climate change. It's not to confuse people, it's to clarify. So when we talk about climate change, what we are specifically talking about is what is called anthropogenic climate change. Um, Basically, climate change caused by human activities. Um, there are natural causes of climate change. They are either too small or take way too long to account for what we've seen. And I'll unpack that later in this course. But when we talk about climate change, rather than looking at one number for the entire world, we are now looking at individual locations and how each of them is responding to this change. For example, some places, such as northern Alaska, are getting way warmer. Other places, such as the North Atlantic, are getting colder. Other places are getting way wetter. Um, Parts of Antarctica have seen a substantial increase in precipitation. Parts of the equator have seen substantial increases in precipitation. Alaska has seen big increases in precipitation. Meanwhile, other places are getting a lot drier. So all of that said, when we talk about climate change, we're looking at individual locations. But even though global warming is a misleading term, it is still happening. Earth's global average temperature has been steadily going up pretty much ever since the early 1900s. We had a tiny bit of a lull in the 1940s and 50s. We'll talk about why that was. But pretty much ever since then, global average temperatures haven't just been going up, but the rate at which they're going up has been accelerating. And guess what? The 5 warmest years on record have been the past 5 years. And every year is just getting warmer and warmer and warmer. On the other hand, what are some other causes or what are some consequences of this? Well, sea ice is melting. If we actually look in the Arctic, so where the North Pole is, the Arctic Ocean, the total amount of sea ice during the summertime, so during the minimum time of year, during the time that chunk of ice is the smallest, has in general declined substantially since the 1970s. We have gone from about 7.5 million square kilometers of ice in the late 1970s, now down to about 4.5. That might not seem like a lot. That's about 40%, meaning that the average summer ice extent has declined 40% just since the 1970s. We're only talking about 40 years here. And it's believed to only get worse. Some of the most dismal predictions say that Arctic summers could be ice-free as early as 2040. That would have major implications on Earth's climate system because ice is really reflective, meaning not as much sunlight is hitting the Earth because of it. We lose this ice, Earth could warm up rapidly. But when talking about climate change, instead of looking at the entire world, instead of looking at one number for the entire world, we're looking at individual locations. This map right here, this is a map of what are called anomalies. And these anomalies are basically differences from average. Um, Wherever you see that light pink, that very, very light pink, that is right at the average. Wherever you see dark pink or red, such as here, down nya, all over nya, over here, right up here, these are areas that have begun to see above average temperatures. And then wherever you see patches of blue, those represent areas of below average temperatures. Um, and some of these were just a 1 year anomaly. This was for 2017. So here, 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 and here. However, some of these have actually been long-term sustained changes in temperature. One that I actually want to bring to your attention really quickly that is very concerning is actually right up here in the North Atlantic. Now, it seems like a small little blue blob, but this small little blue blob happens to be in one of the most concerning places in the entire world. And here's why. If you've ever seen the movie The Day After Tomorrow, that movie is mostly fiction. But there's one piece of really good science in there that is worth talking about. And that science is something called the North Atlantic Current. So heat from the equator and the Gulf of Mexico gathers up on the east coast of the United States, moves its way up the east coast of the United States, and thanks to the geometry of the east coast of the United States, it then begins to take a sharp eastern turn all the way out to this area between Iceland and the United Kingdom. Now, this water is very warm water. In fact, it's some of the warmest waters in the entire world. Well, this very warm water carries a lot of heat with it. And that heat makes its way up into these northern latitudes, the North Atlantic, Iceland, which everybody says is very green, the United Kingdom, which is a relatively mild area, and much of Western Europe. Very well developed, very populated area of our planet. And it has a lot of its heat and a lot of its mild temperatures thanks to this North Atlantic current. The North Atlantic current moves heat up there, and then that heat keeps much of Europe nice and mild. Otherwise, if you notice, most of Europe has latitudes very similar to that of central and northern Canada, parts of the North American continent where very few people live because it's so cold. But thanks to the North Atlantic current, that is not, that part of Europe is a lot more mild. However, here's the concern. As the Earth is heating up, that is actually changing the nature of this current. The reason why is in order for this current to run, somewhere up here, cold, salty water, this water, once it's given off its heat, needs to be able to sink into the lower part of the ocean. It's able to do that because it's cold and because it's very salty. However, as Greenland is melting, all of that melting water is dumping right into the Atlantic. And as it's dumping right into the Atlantic, it is diluting that cold, salty water, causing it to sink at a much slower rate. And what that is actually doing is that is slowing this current down. As a result, this particular part of the North Atlantic is not getting as much heat as it used to. The concern is if this current continues to slow down, that could eventually shut off much of Europe's heat source, and much of Europe could actually see substantial cooling. Now, what will trigger this, when it would be triggered, how bad it could be, we honestly don't know. But it is a concerning idea, and it is an example of how warming can actually lead to cooling. How warming can actually lead to cooling. Um, it's actually believed that this may have already happened once in recent history. In the 1400s, much of the world was pretty warm, and Greenland was actually so mild that Vikings were living on it. Well, during that same time, a lot of the ice in Greenland melted, dumped into this particular part of the ocean, shut down the current, and triggered a rapid cooling trend that killed the Vikings. So, this can actually be very ominous for our future. But all of that to say, just saying global warming and giving that one number, while it's very true and it is very concerning, we need to keep in mind that there's so much more happening, that it's not just enough to say global warming, Earth has warmed up by 1 degree. That's it. Let's go home. That warming has so many consequences in different parts of our world. Now, that being said, is this weather? We'll talk about that in the next video.